Hello, welcome back. Hey, it's Wednesday already. It just seemed like yesterday was Tuesday, and it's amazing how fast this week is moving. By the way, make this the best Wednesday this week. I think you can do it. You know, we're talking in math about geometry. I don't know if I've said this, but it's one of my favorite kinds of math. By the way, if you don't remember, I'm the winner of the Nobel Prize for the discovery of the crouton. Although I don't like to tell people that because it's just, being humble, that kind of thing. But I'd like to today review a little bit about geometry. First, some of the basics. That's called a what? A line. It reminds me of God. This is a what? A ray. This reminds me of people. This is a segment. It reminds me of an animal. This is a point. Get the point? Now, sometimes lines never meet. They're called what? Parallel lines. These lines meet. Therefore, they're called what? Intersecting lines. What do you call intersecting lines that make square, don't look at me, corners? All right, they're called perpendicular lines. Now we also have learned something about angles. Okay, so two rays make up an angle here, right? If that ray or those angles are less than 90 degrees, they're called what? Acute angles. What if they're 90 degrees exactly? Right angles. And what if those angles are more than 90 degrees? They're called obtuse angles. What if they're 180 degrees going opposite directions? Those rays point opposite directions. That's called a straight angle. We also learned about vertical angles. Vertical angles are formed by intersecting lines. And you notice right here, if I increase the measure of the top angle, the bottom angle increases. If I decrease the measure of the top angle, the bottom angle decreases. And so that's the thing about vertical angles. Those vertical angles opposite each other there are always equal in measure. We also learn about complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Wow, hey, you're brilliant. We also have learned something about, over here, classifying triangles. You know, triangles have three sides, they have three vertices, and here's how you write them with that sign, and we learned that they add up to 180 degrees. If you classify triangles based on their angles, if there's three acute angles, it's called a what? Acute triangle. If there's one right angle, it's called a what? Right triangle. And if there are, one obtuse angle in that triangle, it's called an obtuse triangle. That's based on the angles. If you classify triangles based on their sides, okay, so measures of the sides. If they're all equal, it's equilateral triangle. If only two sides are equal, isosceles triangle. Not what? Not isosceles, it's what? Isosceles triangle. What if none of the sides are equal? Is that possible? Yes. They're called what? Scaling triangles. All right. We also learned yesterday, we're talking about classifying quadrilaterals. Now, a quadrilateral has four sides, closed figure, and here's some special ones. If the opposite sides are parallel, it's called a what? Parallelogram. Let's suppose the opposite sides are parallel, so it's a parallelogram, but also they have square, don't look at me, corners. All right? Well, that's called a rectangle. What if it's a parallelogram, opposite sides are parallel, and it doesn't have to have square corners, it could, but let's suppose that all the sides are equal. Well, that's called a rhombus. What do you call now a quadrilateral, parallelogram, rectangle, rhombus? Okay, don't look at me. All right, please. All right, we went through this yesterday, and I'm already emotional about it. Square, it's called a square. Now, if you only have two of the sides parallel, it's called a what? Trapezoid. Have you got your zoid yet? Yeah, right, here's a trapezoid. And so we were finding out that all the angles in a quadrilateral add up to 360 degrees. The sum of the angles of quadrilateral, 360 degrees. Now, I hope you did this correctly because yesterday you were asked to classify as many ways as possible the figure. So if you see a figure like this, don't just say square. No, look at me. All right, don't just say that, all right? But you got to tell me all the things that it is. And you could start with quadrilateral. I think the book said, hey, classify the parallelogram. So we already know it's quadrilateral, already know it's a parallelogram. So then I would say, well, that's a rectangle also, it's a rhombus, and it's a square. So you would say all those instead of just starting with a quadrilateral. Now, today we move over here. And on this Wednesday, we're talking about 9.6. Go to page 485, polygons. Polygons. All right, sounds like the name for a child of a mathematician. Polygon. Yes, that would be a good name for the girl. You know, polygons are closed figures. We've learned about triangles and we've learned about quadrilaterals. Those are polygons, all right? So they're closed figures. They have to have three or more sides. It's impossible to draw a closed figure with with two straight sides. You can't do it. All right, you try it. Try drawing a closed figure with two straight sides. All right, you can't go curving around. It's got to be two straight sides. You try it. Now, so where the sides meet is called, one of them is called a vertex. And then all the sides where they meet, those different points are called the vertices. The vertices. Now, here we've already learned about the triangle. How many sides does that have? 3 sides. We learned about the quadrilateral. How many sides on a quadrilateral? 4 sides. By the way, that looks like a what? There's that trapezoid, right? 2 of the sides are parallel, the other 2 are not. That's a trapezoid. All right, now we're learning today about a quadrilateral with 5 sides. And you're saying, wait, Mr. Frazier, that doesn't look like a pentagon. Well, the definition of pentagon is a closed figure with 5 sides. Okay, so let's see. 1, 2, 3, 4, 5. All right, is that a closed figure with 5 sides? Yes, that's a pentagon. How about this? A hexagon. A hexagon is a closed figure with 6 sides. And you're saying, no. A hexagon looks like something out of a beehive. Okay, well, let's see. 1, 2, 3, 4, 5, 6 sides. Okay, that's a hexagon. How about an octagon? Octagon, you say, no, Mr. Frazier, you are really off today because an octagon looks like a stop sign. All right, we're going to get to that all in a moment here, but let me count. 1, 2, 3, 4, 5, 6, 7, 8. Does that have 8 sides? Yes, therefore it is an octagon. So when you classify polygons, don't go by this, oh, they got to look like that. All right, they can look a lot of different ways. Now, let me get to what you're really thinking about. What you're really thinking about are called, in math, regular polygons. You understand? Not just a polygon, these are regular polygons. What are all the others? Irregular, 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 I think. All right, so these are regular polygons. And they're the shapes that you think of when you think of them. For instance, here, if you hand me, Mrs. Frazier, that soccer ball behind you there on the chair, she's going to bounce that to me. I'm going to pick it up and go ahead. And, okay, here. Now, you notice on a soccer ball that there are different shapes. Okay, so here I see, let's say, where it says Franklin. 1, 2, 3, 4, 5, 6-sided figure. That's a hexagon, right? 6-sided polygon. And right next to it, 1, 2, 3, 4, 5, 5-sided figure is a pentagon. Now, those are what we think of. When we think of a hexagon or a polygon, we think of a soccer ball. Hey, catch, Mrs. Frazier. Now, thank you. Those are called regular polygons. Regular polygons. They have equal side lengths and equal measures for the angles. That makes them regular polygons. For instance, here I have a 1, 2, 3, 4, 5, 6-sided figure. All the sides are equal, and here's how you show the angles are equal. Are you ready, class? This is something new. To show angles are equal, I have that drawing right in there. For each of the angles, it's 1 each, right? One little curved arc for each one, and that shows you they're all equal. So what do you call this? And I know what you're going to say, hexagon. Not good enough now. You're not second graders, okay? We are now in 6th grade. So what we want to say is this. It's something more than just a, hexagon. What is it? It's a regular hexagon. And now you know that because I told you. No, actually the book says so. All the sides are equal, all the measures are equal. It's a regular hexagon. What is this? Well, let's count it. 1, 2, 3, 4, 5, 6. What is that? It's a hexagon. You don't call it a regular hexagon. Why? Because the sides are not all equal and the angles aren't equal. This angle is very tiny and that angle is bigger. That angle is really big. There are, therefore different measures for the angles. That is not a regular hexagon. That one is. Everybody see the difference? And when we think hexagon, we think we've been trained over the years. We've been given pictures of the regular hexagon. All right, but now I want you to realize that's what that is, a regular hexagon. This is a hexagon. What is this? All right, how many sides? 4 sides, so I know it's a quadrilateral, but is it a regular quadrilateral? Well, this side, I would say, is equal to this side, but this side is longer. So are all the sides equal? No. The angles are all 90-degree angles, yes, I would say that. So in a rectangle like this, with the sides not being equal, it is just a quadrilateral. So you write just quadrilateral. Don't write regular quadrilateral. A square, don't look at me, is a regular quadrilateral. But this particular rectangle has sides that are longer than others, and therefore it's just a quadrilateral. I know that sounds a little confusing, but we'll look at this again, and you'll get that, the difference between regular polygons and just polygons. Now, you're going to be asked to do something. I want to show you something that's just a little more involved as far as polygons go. First off, we got to learn what a diagonal is. All right, a diagonal is the measure from the vertex inside the polygon to another vertex. All right, so that's a diagonal. It's a connection between vertices inside. Now, it can't be one of the sides, all right, because I know this particular side joins this vertex to that vertex, but it can't be one of those. To be a diagonal, it can't be one of these four sides. It's got to be inside connecting vertices. So let me pick one of the points, all right, one of the vertices right there. I'll pick that vertex. All right, I'm going to draw a diagonal from that vertex to one of the others. And the only one I can see that I can do that is right over here. I didn't draw that very well, but there it is. Can I draw from this vertex another diagonal? Well, if I go over to this vertex, that's one of the sides. If I go down to this vertex, that's one of the sides. Can't be a diagonal if it's one of the sides. So how many, on a four-sided figure, how many diagonals can I make from one of the vertices? And by the way, these are only, we're talking about regular polygons here. That's supposed to be a square. Don't look at me. Okay, so how many diagonals did I draw from one of the vertices? One. Now, here's something else I want you to notice. When I drew that one diagonal from one vertex to the other, how many triangles did I make inside there? How many triangles did I make? You see them? Well, I see one triangle here, another triangle here, right? So I made two triangles. All right. Let's look at a three-sided figure. I want to see how many diagonals. I'm going to pick this vertex right here. How many diagonals can I draw to another vertex from that one? And it can't be one of the sides. Well, look, if I draw from here to here, it's one of the sides. If I draw from here to here, it's one of the sides. There are zero diagonals, and therefore zero triangles that I make from that one diagonal, or how many diagonals I draw. But let's go to a five-sided figure, and let's go to a pentagon. It has 5 equal sides, 5 equal measures. I know you're thinking, it doesn't look exactly right. Well, I hand drew it, that's what. Okay, so let's suppose you have 5 sides. Let me pick a vertex. I just picked that one. That's pretty handy. All right. How many diagonals can I draw from that vertex to one of the other vertices, but not be one of the sides? Well, how about this one in here? I can draw down to that. All right. Can you see another one? How about if I go from here to there? Can you see any others? If I draw from there to there, I can't. If I draw from there to there, I can't. Remember, I have to always start at the same vertex and draw as many diagonals as I can from one vertex. Well, how many diagonals did I draw? 2? Great. Let's talk a little more loudly. I can't hear you. All right. And how many triangles did that make? 1, 2, 3. Okay. Let's go to a 6-sided figure. What do you call a 6-sided figure that has equal measures on the sides and equal angles? Don't say hexagon, please. Don't. What is it? Regular hexagon. Okay. So let me pick a vertex right there. I could have picked any of the 6, right? I picked that one. All right. Can I draw a diagonal to this? No. Can I draw a diagonal to that? Yes. How about to that vertex? Yes. How about to that vertex? Yes. Any more? No, that would be going to one of the sides, or including one of the sides. How many diagonals did I draw on that regular hexagon? 3. How many triangles did it make? 4? Okay, you're right. It's not a trick. It's not a trick. It's just, you have to make sure you're drawing from the same vertex every time, all right? Don't pick another vertex and start drawing diagonals. This doesn't work. Okay, so I want you to give me a formula for the number of diagonals from one vertex for any regular polygon. Now, D is going to be the diagonal, and S is going to be the sides. So I'm going to put D for diagonals. This is the number of diagonals equals, and I want something here that's going to tell me, you look at the pattern here, how I don't need to draw it. I don't need to actually do this to tell how many diagonals I can draw from one vertex of a regular polygon. All right, so I'm going to do a diagonal will equal S. All right, that's the number of sides. Here, let's go up here. We had 4 sides and 1 diagonal. What do you do to 4 to get to 1? Sounds like you would subtract what? 3? Is that going to work? Let's try it with this one. Okay, so here, the diagonal of a quadrilateral, I have 1 diagonal, and so for a quadrilateral, it would be D equals 4 minus 3. So for a quadrilateral, it would be 1 diagonal. Did that work for that? Yes, it did. I had 1 diagonal, all right? How about for this? For a triangle. So diagonal equals S minus 3, diagonal equals 3 minus 3. And how many diagonals did I get in a triangle? 0. So far, my brilliant formula has worked. Let's try it with 5 sides. The number of diagonals from one vertex in a regular pentagon would be diagonal equals the number of sides minus 3. And that would mean diagonal equals 2. Did I find 2? Yes. How about for this? Diagonal equals 6 minus 3. 6 minus 3 is 3. Whoa, it works. Now, how about this? The formula for finding, the formula for finding the number of diagonals, diagonal minus equals S minus 3. Number of sides minus 3 in the polygon. How about the formula for the number of triangles formed? Here for a 4-sided figure, we had 2 triangles. 3-sided figure, no triangle. 5-sided figure, 3 triangles. 6-sided figure, 4 triangles. Can you give me a formula? D equals what? The number of sides minus what? Well, okay, 4 minus what equals 2? 5 minus what equals 3? 6 minus what equals 4? 2, right? There's the formula for finding the number of, I'm sorry, I'm saying diagonals here. Here I'm talking about triangles. Let me fix that. I'm going to use a different variable. T equals the number of triangles. Here was diagonals. Diagonals will be 5 minus, the number of sides minus 3. For the number of triangles formed, it's going to be the number of sides minus 2. Does that make sense? All right, let's see how that works. So, does that work? Yes. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. Here's what I want you to tell me. Will you send me, please, in a message, the answer to this challenge? Now, it's got to be in a message, all right? Message me the answer to this challenge. If you put it in a post, guess what everybody sees? They see the answer. And I can't give you credit, all right, if you put it in a post. Put this in a message. I want to know how many diagonals from one vertex in a regular octagon. You use that formula to find it. And how many triangles would be formed by those diagonals in a regular octagon, all stemming from one vertex to the others. All right, well, that will help you, I think, in tonight's or today's practice. Thank you for working hard in math. This job, I don't know if I told you this, is my favorite kind of math. See you later.